Our objective for today, I can identify the domain and range of a function. I can identify the domain and range of functions. Tell your neighbor the main concept we're on right now. Yes, that is correct. So this year, Algebra 2 is going to be all about functions, different types of functions. So today's lesson is important, or should I say imperative, that you understand every part of it. Tell your neighbor what I just said, please. Please, so when your noodle starts getting tired, or you start wondering, like going to Barney, or you're on the roller coaster or whatever, come back to us, please, pretty please. There you go. So, functions. Before I define functions, I'm going to cover some vocabulary that we need to know by now. Ready? First vocabulary. You don't have to write this down. Write your utensils down. Look up to the screen. This is stuff that you need to know. First one, ordered pairs. Ordered pairs are what? A coordinate. What makes a coordinate? An x and a y value. Yes? How does that look with numbers? Well, like this. 2, 3. Is that an ordered pair? Yes. Is that a coordinate? Yes. Is that also a point if I was to plot that? Yes. It's all of them all together. Next vocabulary. A relation. A relation is a collection of ordered pairs. So if I was to start asking all of you to give me an ordered pair here, 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 and I put them all together, what is that called? A relation, kind of like this. All these ordered pairs together make up a what? A relation. Does that make sense so far? Is it coming back? Yeah? Kind of, sort of? All right. Next. Here we go. Ready? Domain. So you're like, oh my goodness, I remember these. Domain are all x values of a relation or a function. So let me ask you this. Are all these a relation? Here it goes again. Are all of these a relation? Yes, I said a bunch of ordered pairs together make a what? A relation. So what does domain mean? It means the x values of the relation. So before I move on, look at this. Tell your neighbor the domain of this relation. Now, some of you are looking at like the screen and listening to it, you're like, I have no idea what they're talking about. Well, let me show you. Let's say I take this relation, and it says the domain is all x values. Now, do you see all the x values of that relation? That's the domain. However, how do you write domain? We use a set notation, but we always write it from least to greatest. What would be the least of these? -5 and then -2, 0, 2, and 100. And it should look something like this. Is it coming back? Yes? So if that's true for domain, the range means that all y values of the relation. So look at this. Look at the relation up here again. Tell your neighbor the range of that relation. All right. So therefore, look how I write it. Oh, we're focusing on the y. There it is. And I write it as follows. -3, 0, 3, 7. You're like, wait a minute. Tell your neighbor what you notice from here and these. So you know what you notice? Yeah, you don't repeat numbers, right? If you already wrote it once, you don't repeat it again. And that's true for both, for domain and range. Okay, we got this? All right, functions. Oh, my bad, sorry. Quick review on relations. Remember how to fill these in input-output tables. And then from there, we graph them. Is that correct? And some of you struggle with these. I don't know why. Mapping diagrams. You guys remember mapping diagrams? Some of you are like, I don't think I ever covered that. Well, that's why I'm covering it. So once again, relations can be represented 3 different ways: by a table, graph, and mapping diagram. So if I ask Steven, give me a point. 2, 3. Okay. And then from there, I ask Fernanda for another. 1, 5. Okay. And Noah, another one. And I'm going to say -4 and Okay. Question. What is this called? I just asked for different points. Tell you never what is that called? It's a relation. When you guys put together a bunch of ordered pairs, it's a relation. Are we there so far? How do we represent this in the table? We just write it in. What is the x value for this one? 2, and the y value? 3. The next one? 1. 5, and the next one? -4, 5. Any questions how to put it on the table? Next, how do we represent that on the graph? 2, 3 is right there. 1, 5 is right there. And -4, 5 is right there. Any questions up to right there? All right. Next, to fill out a mapping diagram, pay attention to this part. We fill out all the x values first, from least to greatest. So which one do I write first, Rosina? So far so good? Danica, how about the y? What is it? 3. 5. Do we repeat the 5? No, we only write it once. All right. So now let's indicate it with our mapping. 2 goes to 3. 2 goes to 3. 1 goes through 5. 1 to 5. -4 to 5. -4 to 5. That's how you represent a relation all 3 different ways. You guys remember this? Yes? Simple? All right. What are functions? Functions are relations that have exactly one output value for each input value. Function, a relation that has exactly an output value for each input value. Copy that. Once again, a function, a relation. Can you picture a relation in your noodle now? Yes. That assigns exactly one output value for each input value. So let me show you what a function is according to the definition. Writing utensils down, look up to the screen. Here we go. Don't copy this, you're just paying attention. It says, a relation, is this a relation that assigns for each input value one output value? So let's see. Here's -2. What is the output for -2? 3. Here's -1. What is its output? 4. So far, for each input, we only have one output, okay? 0, its output is what? 5, only one output. 1, its output is 6, one output, okay? Wait a minute, -2, but what did we get over here? What was the output? Okay, here it goes again. For -2, what is the output? So we should get the same thing if the number -2 comes up again, right? Do we get 3 again? Yes, so for each input, we only have one output. That's why that's a function. Copy that, please. All right. So now that we understand what a function is given a relation, now let me show you what they look like in a symbol notation. Ready? Who remembers this? Y equals 2x plus 1. That is a function. But now for algebra 2, instead of just writing it in y form, we replace the y with something we call function notation, which is f of x equals 2x plus 1. So what do you say, Mr. Q, that this is the same as this? Yeah, it's exactly the same. The only thing this one is indicating that it is a function. Copy that. Here goes another. Y equals x squared minus 1. Tell your neighbor how to write it in function notation, please. How do you write this in function notation? Very good. F of x equals x squared minus 1. Let me show you another one. How about y equals 2 to the power of x plus 1? How do you write in function notation? F of x equals 2 to the power of x plus 1. Now, let me show you the graphs so you can remember. Remember when we graph these functions are what? A straight line. Yes? How about these? Remember those? Yeah, our favorite parabolas. The happy faces, you guys remember those? Yeah? Yeah, our favorite. And then last but not least, this one with an exponent. A variable as an exponent are exponential, and they just keep going upward like so. Okay? So all these are the different ways of writing function or function notations, and this is a relation or function. So let me show you what is not a function. Ready? Here it goes. None example. Copy that relation, please. And I'm going to zoom in for those of you in the back. Here it goes. This is not a function. It's a relation because it's a bunch of coordinates or ordered pairs together, but it's not a function. As you're writing it down, hopefully you already started noticing why this is not a function. Talk it over to your neighbor, let them know why this is not a function, please. Why is that not a function? All right, let's see. Victor, what did your neighbor say? -2 repeats. Okay, let's see. Yes, but that's not why it's not a function. Because -2 has how many different outputs? The first one is what? And the second one is what? 7. So it has 2 different outputs. The other one, if it repeats, it needs to be the same output every time. Does that make sense? Yes, Mr. Q. All right, good. All right. Also, copy this graph, please. I know it's not going to come out as perfect as mine, but just try. Copy that. Now, let's see if you remember. This is not a function because if I do the vertical line test, remember the vertical line test? Okay, good. I'm going to draw my scanner on this side. Remember when I told you follow mine with your pencil from far away? You guys remember that from back then? No? Never mind. So I'm going to scan this graph from left to right. If it touches only at one spot, it is a function. So right there, it's touching how many points only? 1 on this graph, so it is a function up to right there, yes? But as soon as it touches more than once, about there, how many spots is it touching? 2. Right here it's 1, and right here it's the other. That's why it's not a function. Or in other words, what values, how many values of x does it have on that part? 2 of them. 2 values of x. Okay? Yeah? Hashtag. Couple hashtags, please. What makes a function a function? Hashtag what? Hashtag what? Man, you guys are like, you look tired. Are you guys tired? Instead of Monday, we should have like a nap day or something like that. You all right? No. All right. Hashtag, Caroline, go. Hashtag what? One output for each input. All right. Chelsea, hashtag what? Relations. Yeah, we got this, yes? All right. All right, so now that we got that, now I'm going to focus now on vocabulary specific for this lesson, okay? So writing utensils down, look up to the screen. You don't have to copy this because I just need you guys to pay attention and understand. Here we go. First vocabulary is interval. Interval. What does that mean, Mr. Q? Interval is a part of a graph that does not have any breaks. The easiest way of I can think of is kind of like if I said, Maria, hold this string, and I'm going to focus on showing you every little piece that's in between the string. That's an interval. But what happens if all of a sudden Cindy gets up and cuts the string in half? Is that an interval anymore? No, because it has a break in between. It has to be continuous. That's why it says a part of a line without any breaks. So far, so good? All right. There's 2 types of intervals. The first one is called finite interval. Finite comes from the Latin root word finito. Who's heard of that before? Finito? No? Some of you? I've heard it, I mean, I've used it before, but finito means, in Spanish, we use the first three letters. You guys remember the word fin, which means end. That means that an interval that has two endpoints, that means that it stops, is called a what kind of interval? Finite interval. So when I ask you to look at a graph, if it stops at both sides, it's finite. How do we indicate that using symbols? Here it goes. We're going to use brackets to indicate that it ends or that it includes the end. Brackets to indicate what? That it ends or that it includes the end. Everybody following so far? What is the other type, Mr. Q? It's called infinite interval. What does the word infinite remind you? That it keeps what? It keeps going. It keeps going either on one side or on both sides. That's what unbounded means. And what symbol do we use that to indicate that, Mr. Q, with symbols? We use a parenthesis to indicate that it keeps going or it's not included in the section that we're looking at. Okay? So, with that said, you have in Cornell's this table. You guys see that? Yes? All right, I'm going to break down the first one, so stay focused, please, because from this point forward, you should be able to put together all the puzzle that we already started with the school year. Ready? Here it goes. Write your pencils down, look up to the screen. You'll copy at the end. Focus, please. If I asked you to write an inequality for this graph, we know we need to start with what? A variable and the dividing point. What's my dividing point? -3. You guys remember that? Yes. Now I need an inequality symbol. How do I write the inequality symbol? Well, I need to test the point, Mr. Q. All right, which number do you want me to test, Allie? Very good. So 0, -3. So out of these two numbers, which one is greater? Look at the number line. 0. So if these were on the scale, 0 is greater. That means it's heavier. It's going to drop, so the arrow is going to point that way. That's why I write x greater than -3. Now, do I write the equal sign underneath? No, because this is a what? Open point. That means do not include -3. Are we there so far? All right. Next, how do you write it in set notation? All right. Solution set of x, and I did such that x greater than -3. However, the book does not use colon like I do. It uses this. Look up. A bar like that. We good so far? All right. So far this should make sense because we practiced all that, right? But let's go to interval notation. Where does it start on the left side? -3. Okay. Where does it stop at the right side? Does it even stop? No, it keeps going to positive infinity because it keeps going and never stops. So the right side of my interval is going to be for positive infinity. So question, look at that. It's an open point. Does it include -3? No, since it doesn't include it, I don't use a bracket. I'm going to use a parenthesis. Do I ever reach positive infinity? No, because infinity keeps going. So can I ever reach infinity? No. So that means I'm going to put in open parentheses. What does this mean in words? All real numbers greater than -3. Question, does this interval continue going? Yes, that means what kind of interval is it? It's infinite because it has to infinite. Copy that, please. Okay, I'm going to move to the next graph. However, I wrote it out because I know some of you have difficulty reading some of my stuff with a tablet. It's not me. I write really pretty, by the way, but the tablet makes me write. Everybody got this so far? 20 seconds? Okay, we're going to do one together. Ready? Let me give you the graph that's up next. Copy that graph. By now you should have your colored pens ready, right? Yay. Okay, I'm going to zoom in so you can see the graph. copy it in your table. All right. So if I ask you to write the inequality for that one, what do I start with, everyone? The variable, which is what? We're going to use right now what? X. What else do I need? Dividing point, which is 4. Okay. Next, I need to test the point to find out which way I'm going to put the arrow, right? Which number do you want to test, Miguel? Okay, so I'm going to use 2 and bring down the 4. So looking at these two, which one is greater or which one is heavier out of the two? The 4, which means if they were on the scale, this side drops, so the arrow is going to point that way. Are we there so far? All right, next, am I done with the inequality? No, this is a solid point. That means it includes, so I put an equal sign. Is it coming back? Yes? I want you to write me the solution set for that one, please. Okay, show your neighbor, see what they got. Very good. Caleb, what'd you get? Solution set what? The thing, the bar, such that? Hands if you got that. Okay, so far so good, yes? All right, let's go to the interval. Interval notation. Look at the left side. What's the beginning point of the left side? Does it have a beginning point? No, it keeps going to what? To the negative side, to negative what? Infinity. That is correct. That's the left side. How about the right side? Does it even stop on the right side? Yes, where does it stop? At 4, so we write 4. So question, is 4 included? Yes, so what do we use here? A bracket, that is correct, to say that it includes 4. Do we ever reach or catch up to negative infinity? No, so this is what? Parentheses, to indicate that it does not include it because it keeps going. So what does this mean? All real numbers less than or equal to 4. And since it doesn't stop, what kind of interval is this? Infinite. So far so good? Show me your fingers how come you are with these so far. That's right there. Yeah, 5, 4, 5, 4. Okay. I'm going to zoom in for the next graph. Ready? Here we go. Copy that graph. That's the next one. And as you're copying that, think, what kind of inequality is this? This looks familiar. Tell your neighbor the type of inequality that is. Everyone. Very good. It's an and inequality. Yes? Okay, so how would we write our inequality from there? What do we start with? The dividing points, yes? What's my dividing point on this side? -2. What's the dividing point on this side? 5. What goes in between? X, and always arrows to the left. Do we need to put equal signs? No, because these points are what? Open, so we don't put an equal sign on either. Write me the solution set on the next column. Solution set. All right. Solution set of x such that, what else? -2 less than x less than 5. Are we there? All right. Does it stop to the left side? Where does it stop on the left side? -2, comma. Where does it stop on the right side? 5. Does it include -2? No, so it's what? Parentheses. How about 5? No, so it's parentheses. What does this mean, by the way? That it's what? All real numbers. What else? Between -2 and 5. That is correct. Now, does this graph keep going on either side? If it doesn't, what kind of interval is it? Finite. Not fortnight, finite. Because it stops. Piece of cake? Showing you how comfortable you are up to right there? Okay, we got this. Let's see if you can do the last one by yourself. Yes? Here it goes. Oh, sorry. Let me zoom in. There you go. Copy that one, and I want you to write me the inequality, solution sets, interval notation, description, and what kind of interval. Copy that and go. Let's see, Monse, what are our dividing points for this? And -1. So that means you write x in between with arrows to the left. But what am I missing, though? On which one? On the -5, she put an equal sign on the -5 because it's a what? It's a solid point. The other side is an open point. This is open, and this is closed. Okay. Let me zoom out. Solution set of x such that -5 less than or equal to x less than -1. Interval notation, let's see. Bracket, -5, comma, -1 parentheses. Hands if you got that. Okay, good. And what does it mean? All real numbers between -5 and -1, comma, including -5. And Chelsea, let's go. And what kind of notation is that, Pedro? Finite. Hands if you got that. Yeah, we got this, yes? All right. And last but not least, we're getting close to the bell, but let me just cover the domain, because some of you still struggle with domain. Look up to the screen. Now, when they're talking about domain, they're talking about a certain section on the graph, but focusing on the x-axis. So look up. I'm going to shade part of it. Look at it. I'm going to zoom in. Tell your neighbor between what two x values is that graph focusing on? 2 and 8. Does everybody see that? That's what we mean about focusing on the domain. I'm going to do that again. Look at this one. Between what two numbers does it focus on? -3 and 3. And so on and so forth. For the range, same thing, but now we go like this. Let me zoom in. Between what two numbers does the range focus on? 1 and 9. All right. So now let me show you how to show if I was to give you a graph. So look up to the screen. If I was to give you this graph right here, I'm going to focus on the domain. Between what two numbers is that graph found? -5 and 7. Do you guys see it right here? So my endpoints are what? -5 and 7. What goes in between to write my domain or my inequality? X, because we're focusing on the x-axis, right? Arrows to the left, but now since it includes these points, we put an equal sign. Does everybody see that? That's what we call our inequality. Can I write this in solution set notation? Yes. Solution set would be what? X such that -5 less than or equal to 5. I mean, x less than or equal to 7. Hold on. Last but not least, interval notation. How do I write this in interval notation? Does it include -5? Does it include 7? So it would be bracket, -5, comma, 7, bracket. Same thing with range. The hopefully is going to ask you either to find the range or the domain of graph. So hopefully you can do that. Have a good one, guys. Enjoy your home plate. And once again, the home plate was found on, what was the pages? Let me see. 12 through 14. Have a good one, guys. See you guys tomorrow. Home plate, pages 12 to 14, problem number 1 through 11. Bye.